our home plate for today is pages 460 and 461 only. 460 and 461. Our objective for today, I can solve rational equations. Once again, I can solve rational equations. So you remember the main concept for today that's going in your prayer model? Rational equations, that is correct. So, what are rational equations? Rational equations are an equation that contains one or more rational expressions. An equation that contains one or more rational expressions. An equation that contains one or more rational expressions. Examples. 6 over g plus 4 equals 2. 2x minus 14 over x squared minus 15x equal 1. 2x plus 6 over x squared plus 5x plus 6 equal 1 over x plus 3. Those are the examples. Here are the non-examples. 6 over g plus 4, x squared plus 3x plus 2, and negative 3 plus x equals 10. Copy that, please, and then I'll go over it with the definition. All right, here we go. So according to the definition, a rational equation is an equation that contains one or more rational expressions. So what does that mean? At least one rational expression. All right, so let's look at this first equation. Does it have a rational expression? Yeah, on the left side, we have 6 over g plus 4. That's a rational expression. And it's an equation, therefore this is a rational equation. Okay, let's look at this one. Does it have a rational expression? Yes, right here. 2x minus 14 over x squared minus 15x. That's a rational expression within the equation. Look at this one. Do we have a rational expression? Yeah, we have two of them. One on the left and one on the right. You guys see it? And it's an equal. Okay? So with that said, look at these. Talk it over to your neighbor. Let them know why these three are not rational equations. Why are these not rational equations? Tell your neighbor, please. All right, Chris, why are these two not a rational equation? Expressions, and this one? It's an equation, but Alejandro? Okay, look at these and look at this one. The definition says the equation that contains one or more rational expressions. Shouldn't you never know why this one's not a rational equation? Do you guys see a rational expression within this equation? No, that's why it's not a rational equation. All right, so hashtag, what are rational equations? Hashtag what? Hashtag what? Tell your neighbor a hashtag, please. All right, Jewel, hashtag what? Equal sign. Pass someone. Jade. One or more rational expression. Okay. We good? Yeah? All right. How about hashtag BAM? Yeah. Anyway, so we get the idea, yes? All right. So as we continue and progress to the second semester, it's going to become a little bit more funner in regards to processes. So I'm going to be giving you the steps for this lesson as I did the other day. So here goes the process. Look up to the screen. It says, when the rational equation is a proportion, cross multiply and solve. Let me repeat that again. When a rational equation is a proportion, cross multiply and solve. Before you start writing these, first of all, what is a proportion? Let me show you. A proportion is when you have a fraction equal to another fraction. To another fraction. Here I wrote a fraction which is 1/2 equal to what? 4 over x. This is a proportion. One fraction equal to another fraction. Once again, proportion. Tell you never what a proportion is. All right. So this is a step when there's a fraction equal to another fraction. What do? Cross multiply and solve. However, Mr. Q, what if we don't have a proportion? So here it goes. If not a proportion, then we identify the least common denominator, or the LCD. Did we do that these past 2 weeks with addition and subtraction and all that? Yes. Then what do? Multiply the entire rational equation by the LCD, and at the end we simplify and solve. Okay? Now some of you already started copying those steps. That's fine. I'm going to leave those to the right. You can copy them as we go along, but I want to get started right away. Copy this example down, please. Example 1 says solve algebraically and identify excluded values. The equation given is 5 over x minus 2 equals 3 over x. 5 over x minus 2 equals 3 over x. Once again, you can finish copying the steps as soon as you're done with the problem, and then come back to the next step and to the next step. Just copy a step along. They're going to be there all day. All right. So I'm going to get started. Ready? It says, when a rational equation is a proportion, look at it. Do we have a proportion? So you never why that is a proportion, please. Yeah, two fractions equal to each other. All right, so what do? Cross multiply. So here we go. Look up, please. I'm going to start with the top right. So I'm going to multiply this times that. That's what cross multiplication is. So what is 5 times x? 5x equals. What is 3 times x minus 2? This one has 2 terms. Is that correct? That means 3 times x and 3 times what? Negative 2. That leaves me with 3x minus 6. Does everybody know where I got this from? Yes? 3 times x and 3 times negative 2. And then it says solve. All right, line down the equal sign. Get all variables to one side. Where do I start? Minus 3x minus 3x. We're left with 2x equals negative 6. Divide by 2. X equals negative 3. That's my solution. Am I done? No, let's check for excluded values. How do we check for excluded values? You take the denominators equal to 0. So we got x minus 2 equal to 0. And what else? X equal to 0. This one's already solved. This one. Add 2 to each side of the equation. X equals 2. So my excluded values are 0 and 2. Now, these should be familiar because we did some of these at the beginning of the school year when we did the review for Algebra 1. Are they becoming a little bit familiar? Yes. Okay. Show me with your fingers how come you are so far up to right there. 5, 5, 4, 5, 4. Okay. All right. Once again, the steps are going to be on top. I want you to do this next one. Once you're done, if you have extra time, copy the next step and so on and so forth. Example 1Q. Copy this. Example 1Q says, once again, solve algebraically, then identify excluded values. The proportion given is 1 over x equals 3 over x plus 4. Copy that and go. I'll give you some time. All right, check your work. And if you got 2 equals x or x equals 2. All right, and excluded values 0 and negative 4. Yes? Tell me if how come you are with these. Okay, do another one. Here we go. Example 1, super cube. Same instructions. You don't need the instructions. You already have them. And the equation given is x plus 1 over x minus 2 equals 4 over x minus 3. We're going to do this one together, but we're going to go one step at a time so we can do and see what we're seeing here. So I'm going to circle x plus 1, and I'm going to cross multiply that to what? X minus 3. But in order to see it clear, I'm going to write them. X plus 1 times x minus 3. Does that look a little bit more clear? Yes. So now we distribute. X times x, x squared, x times negative 3, negative 3x. Now 1 times x, 1x, 1 times negative 3, negative 3. Combine like terms right here in the center. So we get x squared minus 2x minus 3. And we're done with that cross multiplication. So far, so good? Yes, Mr. Q. Equal. Now we cross multiply the other one. 4 times these two terms, x and negative 2. So what is 4 times x? 4x. 4 times negative 2, negative 8. Are we doing it right there? Good? Okay, so now that we cross multiply, it says solve. Okay, laying down the equal sign. To solve a quadratic equation, what do we need? We need it to be equal to 0. So that means I need to make it equal to 0 this, because I got more terms on this side. I need to send all this to the other side. So what do? Minus 4x and plus 8. Minus 4x and plus 8 to each side. This cancels. We're left with 0 on this side. Bring down the x squared. What is negative 2x and negative 4x? That's negative 6x. And negative 3 plus 8, that's positive 5. Do we know how to solve this? Yeah, that looks familiar, doesn't it? What do we do, everyone? 5 and negative 6. So factors of 5 that add up to negative 6. Negative 1 and negative 5. All right. To save time, let's not do grouping. Let's write our two factors. What are my two factors? X minus 1, x minus 5, and all that equals to 0. To solve, what do? Set them equal to 0. X minus 1 equal to 0. X minus 5 equal to 0. And solve. Plus 1 plus 1. X equals 1. Plus 5 plus 5. X equals 5. These are my solutions. Are we done? No, Mr. Q. We need to check what? Excluded values. What were our denominators? X minus 2 and x minus 3. So I'm going to write x minus 2 equal to 0, x minus 3 equal to 0, and solve. Plus 2 plus 2, x equals 2, plus 3 plus 3, x equals 3. So my excluded values are 2 and 3. Yes? we check for the excluded values. We always use the denominators. Yeah. Show me over here how confused you are with those so far. Once again, we've been looking at what? Proportions. Have you guys noticed that? Have you guys noticed all three examples were what? Proportions. So what question is wondering in your noodle? Very good. What if they weren't a proportion? Bam. Copy example 2. Example 2. Example 2, we have an equation. Here it is. 6 over x plus 2 minus 10 over x equals 4 over 2x. Now this is not a proportion because now we have 3 different fractions. So you're like, Mr. Hugh, so how do we get rid of those fractions? Yeah? Kind of like the warm-up, we need the what? The common denominator. Or as I wrote here on step 2, identify the least common denominator. Okay? So I'm going to zoom in first to identify our LCD. I'm going to use red to follow this color. There it goes. I'm going to zoom in. Look up. So I'm starting with these 2 denominators. In order to make this one look like that, I need to multiply this one times what? Times 2. So my common denominator would be 2x for those 2. Is that correct? Yes. Okay. However, Mr. Q, I have one more denominator. Question. Can I multiply 2x to make it look like this? No. Can I multiply this times something to make it look like this? No. Therefore, I need to take this denominator and this denominator, multiply them. So my new common denominator for all 3 of them is 2x times x plus 2. How are we doing? All right, I'm going to zoom out. Now that I have my LCD, okay, just I need more space to do the work. I'm going to rewrite it over here. I'm going to write 2x, x plus 2, and I'm going to write my equation right here so you can see the process. I'm going to write 6x plus 2 minus 10 over x equals 4 over 2x. All right. So, step 2 says multiply the entire rational equation by the LCD. So pay attention to this part. I'm going to do that in blue. Look up, please. Here it goes. The LCD times the first term. So I'm going to write 2x. Oh, hold on. I'm going to use the color so that you guys can have it the same. So I multiply this times this, which means I'm going to have 2x times x plus 2 times what's in the numerator? 6, and all that over x plus 2. Some of you are saying, look up, why not the denominator, Mr. Q? Because the denominator for this would be an invisible what? An invisible 1. So 1 times this is that. Is everybody following up to right there? Okay, next, I'm going to multiply this now times the second term. So what do I write again? 2x, x plus 2. And what do I have here left? Times negative 10. Because the negative goes with that. All that over x. And then, now I'm going to multiply it times the third term, or the last fraction over here on this side. So I have 2x, x plus 2, times, what do I have here? 4 over 2x. Bring down the equal sign, and here we should have a plus, in the meantime, while we do the distribution. Are we there so far? Okay. Now, let's simplify. Sorry. Let's simplify those fractions. Do you see a giant 1? Right here? There it is. So that leaves me with 6 times 2x, which is 12x. Do you see a giant 1 for the second one? The x and the x, is that correct? So that leaves us with, what is negative 10 times 2? Negative 20, and we distribute that to these two terms. So that leaves me with negative 20x and negative 40. Everybody following up to right there? All right. Equals 2. So you see a giant 1 on this one. Yeah, what is it? The 2x. Distribute the 4 in here. So that leaves us with what? 4x plus 8. All right, let's solve. What do I do next? Combine like terms. So what is 12x minus 20x? Negative 8x minus 40 equals to 4x plus 8. Get all variables to one side. I'm going to start with the smallest one, which is negative 8x. So I add 8x, add 8x. That leaves me with negative 40 equals 12x plus 8. All right. Next, minus 8 minus 8. Negative 48 equals to 12x. And last but not least, divide by 12. Divide by 12. Negative 4 equals x. So what's going to be our challenge, guys? I think our challenge will be to identify first what? The LCD. But the second challenge would be to what? To make sure we remember to distribute that to all terms on the equation and then identify giant ones. Okay? Let me zoom out. There it is. However, are we done? No. Excluded values. Our denominators are what? X plus 2 equal to 0. What else? X equal to 0 and 2x equal to 0. This one's already solved. Divide by 2. X equals 0. And this one, minus 2 minus 2. X equals negative 2. So my excluded values are 0, negative 2. Show me with your fingers how come you are with me so far. 5, 4, 5, 4. Yeah, so basically it's just work. It's just expanding more work. But other than that, it's stuff that you already know how to do. Let's do another one similar to this one. However, haven't you been asking yourself a question why we keep doing the excluded value? Has that rung a bell yet? Check this out. The excluded value we keep doing in order for us to identify what number will not be a solution to the equation. That number has a particular name. Look up. That value is known as the extraneous solution. Extraneous solution. Extraneous solution. I like saying that. Extraneous solution. What is it? If the solution of a rational equation is an excluded value, then guess what? It cannot be a solution. Let me repeat that again. If you solve a rational equation and one of the solutions is an excluded value, then could it be part of the solution? No, automatically it's disqualified. That's what we know as extraneous solution. So, with that said, copy this one. Example 3Q. All right. Do we have a proportion? Yes. All right. So I'm going to start on this side. 2 times these two terms. So what is 2 times x squared? 2x squared. 2 times -1, -2 equals -x minus 6 times x plus 1. I'm going to do the multiplication on this side. X minus 6, x plus 1. So x times x, x squared. X times 1 is 1x. -6 times x, -6x. -6 times 1 is -6. Combine like terms, so we end up with x squared minus 5x minus 6. All right, let's solve. What do you guys want me to do? Send all these 3 to the other side or send these 2 to this side? These 2? All right. Minus 2x squared plus 2. Minus 2x squared plus 2. We're left with 0 equals -x squared minus 5x minus 4. Do we know how to solve this?
Yes, Mr. Q.
What do we check first? Which is -1 RGCF. We're left with x squared plus 5x plus 4. All that equal to 0. Let's see. Power Rangers 4, 5. Factors of 4 that add up to 5. 1 and 4. To save time, instead of grouping, let's just write our factors. What are our factors? X plus 1, x plus 4. Bring down the BFF. And now we just write all that equal to 0. -1 equal to 0. Is that true? No. X plus 1 equal to 0 and x plus 4 equal to 0. So if we solve, what is here? -1. And what is here? -4. All right. Excluded values. Just by looking at it, look up, guys. Look the first denominator. X plus 1 equal to 0. What is my excluded value? -1. Do we have that in the solution? This one. So right there in red, I'm going to do this. Not a solution. Why? Tell your neighbor. It's an extraneous solution, which means even though it's a solution, it can't be part of the solution because it's an excluded value. Am I done with the excluded values? No, the other denominator was x squared minus 1, which means x plus 1, x minus 1. So that means the excluded values are -1 and 1. And we're done. Solution is x equals -4. Have a good one, guys. Enjoy your home play. Home play for tonight, once again, is 460 and 461 only. There is tutoring. It's free. Not make it a family math night. Gather around. Have a good one. See you guys tomorrow. Bye.